continue with. Okay, I will continue with the Hermite curve. Okay, what does it mean by Hermite curve? Once again, in the previous slide, you have known about the tangent vector of the curve, right? So do you know that if you want to define a curve, right? For example, this one, Hermite curve, right? I would say that we can easily define it by using two things. The first one is Hermite curve can be defined by two endpoints of two endpoints. Two endpoints mean from this figure, two endpoints mean P1 and P4. P1 and P4. And the tangent vector to the curve at this endpoint, that is R1. Let me change to green color. R1 and R4. R1 is a tangent vector at this point P1, and R4 is the tangent vector touching the curve at P4. So if we know four things, P1, P4, and R1 and R4, so we can draw or we can find a Hermite curve. This is a Hermite curve. How can we form this Hermite curve? Okay, I will go to the next one. Okay, this is the conclusion of, this is the definition of the Hermite curve. So if you want to define a Hermite curve is a curve that satisfies two conditions. The first one is it passes through the first and the last endpoint. You can see that pass to the first, that is P1, and the last endpoint P4. And it has the given tangent vector at the endpoints, at two endpoints. We have two endpoints. P1, we will have R1, and at P4, we have R4. So for Hermite, you may be familiar with the Hermite curve in Illustrator. If you want to define a curve with two ending points here, and then you define the tangent vector, right? That is passed through these 2 points. So you can get the curve here. But you don't know about the mathematical equation of Hermite curve. So if you want to draw this curve, this pink one, this pink curve, what you have to do is you have to find the mathematical equation of this curve. How can we get it? How can we derive the equation?
Ajahn, through the coordinates equation, form an equation through the coordinates.
To the coordinate. Suppose it is given two endpoints, the coordinate of two endpoints, and we also give you the tangent vector at that point, at those points. Can we get the mathematical equations?
Mathematical equation. Ajahn, I don't know.
Okay, no problem. I'm going to tell you. Okay, we can go to the next slide. Okay. Okay, first of all, we have to define the Hermite curve, right, in terms of the cubic. I would say that Hermite curve is a cubic. Cubic means the maximum cubic curve. Cubic means the highest degree is equal to 3. So first of all, you have to define the equation, parametric equation. But it seems to me that it is tedious to write down 3 lines in a row. So I use this one that is shorter. QT is equal to AT 3 plus BT square plus CT plus D. Okay, this is the general equation for the Hermite curve. And once again, it is a cubic because the height CP is 3. Okay, so what we have to do next is we have to find A, B, C, D. Okay, but it is given. Okay, it is for Hermite curve, you have to give me P1 and P4. Let it be the 2 variables, and it has to define R1 and R4 as well, which are 2 tangent vectors according to P1 and P4 respectively. And then, as I just showed you, we have to determine A, B, C, D here. Okay, and QT is a Hermite curve. When QT is a Hermite curve, when I substitute T is equal to 0, what will be the coordinate? When we substitute T by 0, what is the result?
Ajahn, P1 and P4, R1 and R4 will be the coordinates.
P1 and P4. No. You have to answer only one. QT is when T is equal to 0, it is equal to P1. Can you see this?
Yes, Ajahn, I understand
Okay,
it now.
when you substitute T by 0, right, you can get P1. And similarly, when you substitute T by 1, so you can get P4, the last endpoint.
Yes, Ajahn, I understand it now.
Okay, you get the point, right? How about the others? 2 คนเขาทันไหมเอ่ย Can I hear your voice?
yes พอทันอยู่ครับ
Okay, that's good. Okay, so I want to make sure that you can follow me because this is quite important. Because you have to know that when you substitute T by 0, you can get P1. And when you substitute the same curve, when T is equal to 1, so you can get the last endpoint. Okay, so when T, okay, this is the explanation for this line. When T is equal to 0, right, you substitute Q or you substitute T by 0. Actually, it means that you substitute in this equation AT raised to the power T plus BT square plus CT plus D, right? When T is equal to 0, right? This term are gone. And then we can got D, right? And D is equal to P1, right? I've told you that when you substitute T by 0, you can get P1. And when you substitute T by 1, you can get P4, right? So this way you, this line, this equation, you can get D is equal to P1. And when you substitute T by 1, you can get A plus B plus C plus D, right? A plus B plus C plus D. Substitute T by 1 will be equal to P4. And we keep this as the second equation. Okay. Pass. Okay, coming back to the QT equation, QT is equal to AT plus BT square plus CT plus D, right? If you find the derivative of QT, derivative of QT is Q prime T, right? Q prime T is equal to AT ATT3, which is equal to 3AT square plus 2B3 plus C. The same. Derivative of this derivative of QT, which is tangent vector, that is Q prime T. It is equal to 3A T square plus 2BT plus C. And then once again, we substitute T by 0 and T by 1. You can get R1 and R4. R1 and R4 will be the third and the fourth equation. And then we substitute T by 0. These two terms will be gone, right? So C is remaining. So C is equal to R. And we substitute T by 1. So you can get 3A plus 2B plus 3, plus C, which is equal to R4. R4 is a tangent vector at the point T is equal to 1. When we are considering the tangent vector Q prime T, T is equal to 1. So we can get 4 unknowns. So we will have four unknown. For unknown, that is A, B, C, D. Am I right? And we have 4 equations. We have 4 equations. So we can solve this system of equations, right? We can solve this system of equations easily. So you can find A, B, C, and D in terms of R1, R2, P1, and P2. Okay, we have 4 unknowns, right? 4 unknown A, B, C, D. These 4 unknowns will be used in Hermite curve equation. But we have known in advance, or the question is the question gives us P1, P4, R1, and R4. That are the first and the last endpoint and the first and the last tangent vectors of the curve, right? So we can find A, B, C, D by solving this system of equation. Okay, so when we solve, right, A plus B, right, from 2, we can get A plus B, and then we can come up with 5. I'm not going into detail of this solving the system of equation. I will go to the result. That is A is equal to this. You can see that it can be written in terms of P1, P4, R1, and R4. And B is this. C is the tangent vector. D is the first endpoint of the curve, the Hermite curve. So what we are going to do is we are going to write the Hermite curve. Hermite curve, as I just told you, right? It is a cubic, right? So it can be written in terms of QT, right? What we want to do is we have to write it in terms of P1 and P4, R1 and R4. Why? Once again, if you could remember, if you want to define a Hermite curve, right, you have to know first and the last endpoint. You have to know tangent vectors, 2 tangent vectors. So if we can find this, and this, so we can call F1, F2, F3, and F4 are bending function or basic function of Hermite curve. So what can I do? How can I do? So this is the general form of cubic curve. General form of cubic curve, right? In terms of AT raised to the power T plus AB square plus CT plus D, right? So what we do next is we have to substitute. We have known that A, B, C, D, right? You have known the result before, right? You can solve this, right? You can get A, B, C, and D from the previous slide, and then you can substitute A, B, C, D to here. Okay, just simply substitute into the equation. So the next thing that you are going to do is very easy, pretty easy. Okay, let me erase some dirty things here. Okay, what we are going to do next is we want to write this equation. We want to write this equation in terms of P1, P0, oh, sorry, P1, P4, R1, and R4, right? But you have to get the factors. Okay, from this first term, right? You want to get P1. This is P1. What is the coefficient of P1? -2 multiplied by -P1. So you can get 2P1 T raised to the power 3, right? But we want to write P1, right? We want to get the factor out of this parenthesis or these bases, right? So, to make it equate, right? P1. So 2 T raised to the power T will be here. Okay, I do step by step, nah? -2 minus P1 T raised to the power 3. So you can get plus 2 P1 T raised to the power 3. But this one is equal to plus 2 T raised to the power T P1, right? So this Hermite curve, we want to write it in terms of P1. So we want to make these two equations equate. These two equations. When we equate these two equations, so we can combine them, right, into another form, the form of P1 instead of T raised to the power 3. So you can get T raised to the power 3. Okay, I will try to do it again. This one is for the first term. The second term, T raised to the power 2, T squared, right? This is P1, right? 3 P1 minus T squared. So you can get minus 3 T squared minus 3 T squared. And this one is P1. P1 is the coefficient here is plus 1. Coefficient สัมประสิทธิ์นะ plus 1, right? So this one is plus 1. So we can do the same thing, right? To this term P4, right? Minus 2 P4 minus 2 T raised to the power 3 and P4 3 P4 plus T raised to the power 2 square. Okay, this is the coefficient for P4. And how about R1? R1 is plus 1 T raised to the power 3 minus 2 T square minus 2 T square, and then R1 plus 1 T. We have T here plus 1 T. And the last one, R4 1 T raised to the power 3, 1 T raised to the power 3, and then R4 here minus R4 T raised T square minus 1 T square. Okay, so you can get these three results, which is F1, F2, F3, and F4. If you cannot follow this because I record this record the video for today's video so you can recall it again. Okay, no problem. Okay, here we go. We have F1, F2, F3, and F4. So we can have the general form of the Hermite curve, which is in terms of this, right? This is F1, F2, F4, F1, F2, F3, and F4. So this we can call bending function of a Hermite curve. Of a Hermite curve. Okay, here we come to the last two pages of today's lesson before we go to the Mathematica program, right? Normally, when you can get the mathematical equations, normally when we will show or we will have to use this polynomial, right? When you are trying to implement it, you have to represent it in terms of the metric representation, right? In order to use the polynomial. We are not going to use a polynomial. Okay, what does it mean by polynomial? Here is a polynomial. Right? We are not going to use this. Right? We will use metric form. So it's very easy to make it to be the metric form. Why? We will put P1, P4, R1 and R4, R1 and R4 into the first matrix. So it's very easy, right? You can just use GMT. QT is a Hermite curve. It can be written in terms of three metrics, GMT. T is written in terms of P1, P4, R1, and R4. T is a column matrix represented by T raised to the power T, T squared, T, and 1. And this one, M, is a metric representation of Hermite curve. It is represented in terms of coefficient matrix. Only coefficient will be displayed here. It's pretty easy. Okay, starting from this term P1, 2 minus 3, no T here, so 0 and 1, right? 2 minus 3, 0, 1, 2 minus 3, 0, 1. Okay, once again, this term P4, minus 2, 3, 0, 0, minus 2, 3, 0, 0. And then 1, minus 2, 1, 0, 1 minus 2, 1, 0, and then 1 minus 1, 0, 0, 1 minus 1, 0, 0. Okay. So you can just pick up the coefficients from this polynomial right away to this matrix form, metric representation. So when you multiply this, and this all together, you can come up with this polynomial as well. So here we have, this is metric G, metric M, and metric T. Okay, so today I'm going to write down. Okay, the next topic will be Bezier curve, but I don't think we can have enough time for explaining the Bezier curve, so I will leave it for next week class. Okay, so this has the next thing that I would like to show you is I will show you how to write a program for mathematical program for representing the Hermite curve. So let's stop